Hello everybody and welcome back to another visual pattern challenge. We've got a really interesting one today for our last pattern in this series. Sorry to say, but we're stopping after 200. So here's our pattern. I think blue is step one. So this is color coded. So blue equals 1, green equals 2, red equals step 3, and yellow is step 4. So your challenge would be to predict the total number of rings, so all the rings that will exist in step 5. So how many rings will there be? And if you can do that, how many rings would there be in step 43? So that's the challenge. If you'd like to accept this last challenge, pause the video and see what you can do. All right, so this, you can see we've got a little mouse symbol, hand symbol here. This is actually a three-dimensional model that somebody made, and so we're going to take a look at this to start so you can see it a little better. So we can kind of look at it from all angles. It's kind of cool looking. And if we think about it step by step, it clearly started with one ring, and then that ring got two more rings added to it, two smaller rings, and the green ones. And then each of the green ones had two red ones added. So that was 4 added there. And then each of the red ones had two yellow rings added. So there are 4 red ones, so we have to add 8 of the yellow rings. And we assume it would go on and on like this. So let's think about this and maybe chart out the numbers so we can see what kind of a pattern this looks like. Do you have an idea of what kind of a pattern this is? Is this linear? Is it quadratic? Is it something entirely different? What do you think? All right, well, let's chart the numbers. So we're going to do the step number and the number of rings. And in step 1, we just have that one blue ring. In step 2, we've added 2 green rings, so the total then would be the blue ring plus the 2 green rings, so that's 3 in step 2. In step 3, we've added 4 rings now, 4 red rings, so that would be 7. And in step 4, we've added 8 yellow rings, so that would add up to 15. So if we take the difference between each step, 3 minus 1 is 2, 7 minus 3 is 4, and 15 minus 7 is 8. Let's predict step 5 just by following the same pattern. We would take some other color ring and add 2 of them to each of the yellow rings. There are 8 yellow rings here, so we're going to add 16 more. So this would be a difference of 16. So 2 for each of the 8 yellow rings would mean 16 more rings, and 16 plus 15 would be 31. So that's my prediction for the next step, for step 5, would be 31 rings. And we could try taking the differences of the differences here. Since we didn't get a constant, we know it's not linear. So 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8, and we still don't have a constant. And we could actually, if we had enough data here, we could keep going and going, and this pattern would repeat itself. Do you remember what kind of a pattern we have when we see this 2, 4, 8, 2, 4, 8 repeating itself forever in the differences? This pops up when you have an exponential, so something to the x power. And the question is, from what you can see in the differences, what is its, is it doubling, tripling, quadrupling, etc.? And in this case, it's clearly doubling. It goes from 2 to 4, 4 to 8, 8 to 16, 2 to 4, 4 to 8, etc. If it's doubling, it means it's 2 to the x power, and that's sort of our starting point for the equation. This isn't going to work for us, though, at least not exactly as it is, because 2 to the first power, if you plug in 1 for x, would be 2. 2 to the second power would be 4, and we've got a 3 there. 2 to the third power would be 8, and we've got a 7. And actually, now that I'm noticing this, it looks like we're always 1 less than 2 to that power. So 2 to the fourth power, 2 times 2 times 2 times 2 would be 16. This is 15. We have 1 less. 2 to the fifth power would be 32. We have 31. That's 1 less. So I think I can just take this and subtract 1 from it, and that would be our equation. So this actually would work with all of these steps. We just saw that as I talked through this, but if you want to re-verify it, plug in those numbers 1 through 5 in here, take take 2 to that power, then subtract 1, you should get all these numbers. So our equation here is y equals 2 to the x minus 1. Tricky to get there, kind of a cool looking equation. Now, to determine the number in step 43, we're just going to plug 43 in for x, but taking 2 to the 43rd power, you know, what is that? That's pretty crazy. Well, I happen to have GeoGebra still open, and it's not just a good graphing tool. It's also it's got this pretty great built-in calculator. So I'm just going to type in 2 and then power symbol. Whoops, did I get that right? To the 43rd. So there's 2 to the 43rd. And then I'm going to hit the forward arrow so I'm not up in the power anymore. And then just subtract 1. So whatever this number is, let's see. There's thousands, there's millions, there's billions, there's trillions. So 8 quadrillion, 796 trillion, 93 billion, 20. Oh, wait, no, I did that one too many. So there's hundreds, there's thousands. Yeah, there's thousands, there's millions, and these are billions. Gosh, it's so easy to lose count here. 3, 6. Yeah, so it looks like 8,796,093,022,207 is how many rings we'd have total in step 43. Do you agree with that? Well, how did that go for you? Did you get 31 for the next step? Did you see that this was an exponential equation? I would really love to hear about it, and I'd love to hear what you thought of the whole series. If you've got patterns you'd like to send me, I would be happy to come back once in a while and do them. But as a series, we have come to a close. So thank you for going on this journey with me, and I'll see you all again soon. Thanks, everybody.